All right, let's see how you're doing on your inference with two proportions. So here on this problem, we have got Canadians and Brits. And so we want to compare their literacy rates. So that's what we have going on here. So it talks about how this is based off of their literacy rates are based off of the past year, the ones who have read at least one book in the past year. So here we go. Do these confirm a higher reading rate in Canada? So I defined. Now we have that for our parameters. P with a little c is the proportion of Canadians who have read at least one book in the past year. Now, remember how we don't want to have past tense, but I don't think saying who have read, this is like currently the current Canadians who say that they've done that thing in the past. Okay, so this is the present Canadians who say something they did. All right. And then the same thing for the Brits, the proportion of Britons who say that they have read at least one book in the past. Okay. So our hypothesis statements, of course, null hypothesis with those being equal. And the question wants to know if we have a higher reading rate in Canada. So since it's doing it in terms of Canada, I like to write this first because that way when I go to my calculator, and I have to put the sign in there, I do P1 and then it compares it to P2. So I'm seeing if P1 is greater than P2. All right, alternative or our assumptions. So here we go. I color coded these. So I've got for random, it was stated that we had 1,014 randomly selected Canadians and 1,009 randomly selected Britons. The independent, so color code again, I've got 1,004 less than 10% of all Canadians and 1,009 less than 10% of all Britons. And then again, here's that new piece to this. Assume that these Canadians and Brits are independent of each other. So I do not have a person who's a British Canadian, okay? Somebody who's counted in both of those categories. All right, large enough. So that is, so see how I separated this Canadians here. So I have the at least 10 successes and failures. And I don't have, okay, so we do not have true P in this problem. These were the sample results for the Canadians, and these were the sample results for the Brits. So that's what I wrote here because we don't have true P. So I use the sample results, and they were greater than or equal to 10 for the Canadians and for the Brits, 837 and 174. So then approximately normal model applies. All right. So let's see. N is the 2 proportion Z test. And so here is what I put into my calculator. I put my Canadians in first and my Brits in second. So I am seeing if P1 is greater than P2. Okay. And so if you got like an opposite p-value than that with something in the high 90s, then you probably did this wrong direction tail in your calculator. So our p-value is less than alpha. Therefore, we reject HO. So since our p-value is less than alpha, I reject HO. There is evidence that the proportion of Canadians who have read at least one book in the past year is greater than the proportion of Britons who have read at least one book in the past year. And answering the question, do these results confirm a higher reading rate in Canada? I don't ever like to say proof or confirm. So these results do suggest a higher reading rate in Canada. Okay, now so let's talk about the next one. So actually, before we look at this next one, I just wanted to remind you that what we just decided on number 1 is we said evidence of a higher reading rate in Canada. Okay, The reason that's interesting is because we're going to perhaps find something different conclusion with this number 2. And I'm going to do a separate video that I want you to watch and understand as to why did we happen to get a non-corresponding results on those 2 problems. Okay, it's kind of interesting to think about why that happened. Okay, so here it says find a 99% confidence interval. So let's see what that difference is for that difference in the proportion of Britons and Canadians who have read at least one book in the past year. So my parameter and assumptions are the same as the previous page, so I'm not going to do those again. And the name of what I'm going to do is a 2 proportion Z interval. So I came over here, and once again, I have my Canadians first, my Brits second. I'm doing a 99% confidence interval, and here's the interval it gives me. I put the direction that I am subtracting Canadians minus Brits because it's the first ones minus the seconds. So this is interesting. So what's alarming about this is what's very interesting about this interval, of course, you should notice, I have one negative and one positive. So I'm 99% confident that the proportion of Canadians who have read at least one book in the past year is between 1.15% lower than, or lower, up to 7.16% higher. So that proportion for the Canadians could be lower, could be higher. Okay, then the proportion of Brits who have read at least one book in the past year. And again, remember that for our intervals, we are very interested in if 0 is in there or not, and it is. So essentially, we're saying that we do not have evidence of a significant difference since 0 is in the interval. There is no significant difference. We have no evidence of a significant difference. No evidence of a significant difference. Okay. So let's think about that. No evidence of a significant difference. But wait a second. What did we just say in part 1? Evidence of a higher reading rate in Canada. So that's no go. That should be alarming to you, and you should go, wait a second, let me go stop and think and see what happened, and see why am I getting a different decision, okay? Because those don't jive, and they should. So I'm going to have a separate video on that, and we will watch that one. But I don't want it to get buried down in this video, so I'm going to do it separate. Okay, number 3. We wanted to just see what our null and alternative hypothesis statements are. We thought they were wondering if the state or the SAT, proportion of SAT, students who take the test in Texas, who take the SAT, is higher than the proportion of Texas students who take the ACT. So I noticed that all of my answer choices revolve around subtraction instead of doing this 2 separate ones on either side of the sign. So this is kind of the way I personally think about it first, and then I go find which one is it equivalent to over here. And it was E. And here we go with this one. Wow, this one was pretty lengthy. Hey, but you know what though? This is a study that my husband is currently a part of. Okay, so that's why I went through the pain of putting all that in there. Okay, so my husband's heart doctor, he had failure at the beginning of the summer, and his heart doctor is part of a study. He's on the cutting edge of all these different things, and he does a lot of research to see if this addition of a diabetes drug that you take in addition to your regular heart failure regimen reduces, or let's see, here's what we were measuring, increases the proportion of people who have heart infraction improvement. Okay, so lots of words in there. So I kind of highlighted that out. We want to know if taking the diabetes drug compared to only taking, diabetes drug in addition to the regular regimen versus only taking the regimen. And we want to see if it significantly increases the proportion of people who have heart infraction rate improvement. So therefore, let's see. Of course, having evidence means you have a p-value that is less than a particular alpha. So let's see what happens. Okay, so I actually had to kind of go through a whole test on this thing. So again, this is one of those problems where they get you. They see if you know how to do a whole hypothesis test just in a little bitty multiple choice question. So here is what I kind of did before I looked at the answers. So P with the subscript D are the proportion of people with heart infraction rate improvement who take the regular drug regimen plus the diabetes drug. And P with a little r is the proportion of people with heart infraction rate improvement who take the regular drug regimen only. And so the null hypothesis is that those are equal, but alternatively, we wonder if the improvement for the diabetes drug is greater than that of the regular regimen. Okay, so the diabetes drug had 140 out of 400 improvement. The regular regimen had 100 out of 400 improvement. So that gave a z-score of 3.09 and a p-value of 0.001. So see this low p-value. So you would be significant at whatever level you are less than. So that's the p-value. What alpha is that p-value less than? Okay. So there is convincing statistical evidence at the significance level of 0.01. And the reason is because our p-value was less than an alpha of 0.01. So this one says convincing statistical evidence at a level of 0.05, but not at 0.01. So that would have happened if something had been in between 0.05 and like 0.02. Something had been 0.02, 0.03, 0.04. That would be what C is. So you had to compute that p-value. D, there's convincing statistical evidence at the 0.10, but not at the 0.05. So that would have been a p-value of 0.06, 0.07, 0.08, 0.09, any of those ones in between there. How about this? There is not convincing statistical evidence at any reasonable one. Yeah, so that would be like if the p-value was greater than 10%, then we would say there's pretty much not statistical evidence. Okay, is that what we got? Here we have this. We've got our two-tailed test. We have our alpha. So look, the interesting thing is they gave us a z. This is an interesting problem. So when we put our information into the calculator, when you do the calculator and you choose that little two-tailed symbol, the calculator will compute the two-tailed p-value for you automatically. But here is a problem that you couldn't do in your calculator. You had to understand the whole process of two tails and how to do that yourself without the calculator. So this was a problem where they have the z-score. So they give you the z-score of 1.85. Okay, so let's think about what that is saying. So I wonder if I drew a picture down here. Yep, I drew a picture. Perfect. I drew this picture. See, look. Here's the z-score of 1.85. So you would do this. You would see what the p-value is. Let's see. What was this question asking? Oh, yeah, it's just a not equal to. Okay. So more extreme would be going up. So if we go up, then that is the p-value of that upper tail. And so I norm CDF from 1.85 to 99, and I get 0.032. Okay. But remember, it's a two-tailed test, so I need the p-value of both tails. So this is kind of like the other one that you have to put with it. So therefore, the combined p-value of the two tails is 0.064, which is greater than 0.05. So since it is greater than 0.05, see, look, here it is. Since that p-value of 0.064 is greater than the alpha of 0.05, I would fail to reject. So then I would not reject. So I do not have evidence of the HA. Okay, I think that might be all of it. Yes. Okay, so there we go. And don't forget that I'm going to make a short little other video about why there was a discrepancy between the decision for number 1 and the decision for number 2. All right, so make sure you go watch that one because it's very interesting to see what the deal is there.